Yesterday we talked about lateral area and surface area. Lateral area and surface area, think about wrapping paper. That is what lateral area and surface area represent, painting the outside of an object. Volume is filling the can with paint, filling something up. It is a solid. So volume is talking about filling it up with water, and lateral area and surface area is talking about wrapping it. So just keep that in mind, especially when you get to word problems. Now you'll notice that the formulas are similar though. The formulas for lateral area and surface area for prisms were pH and pH plus 2b. We used P for perimeter of the base, and B was the area of the base, and then H was the distance between them. We used the same variables here. Capital B stands for the area of the base, so that's all your two-dimensional objects. That's all of these formulas up here. And then H is the distance between the bases, so how far it is between them. Again, highly recommend that you highlight your bases and then your height so that you can find it really easily. Okay, so you look at your prism. We know that this is a prism. You need to know what prisms look like so that you can find it on the formula chart. So we're looking for volume today. This is my base. We're looking for congruent and parallel. In this case, you've got a lot of options, but because it is a prism and they're all rectangles, I'm just going to use the one that is actually on the bottom. And then the height, right? If this is the base, then this is the other base. So the height, the H that we're going to use in this problem for finding the volume is going to be that one right there. Okay. Now, ignore everything else, right? We need to find B, area of the base. B, that's a rectangle. You go over here, you find your formula for your rectangle. B is the area of the base, which is the base and the height, the length of the base and the height of the rectangle. So the length of the base would be 6. The height of the rectangle would be 2. This is a rectangle. I know it looks like a parallelogram, but remember it's drawn in perspective. So the area of the base is 12. The area of that rectangle is 12. So I want the volume. Volume is the area of the base times the height. The area of the base is 12. The height is 4, right? It's the height, the distance between the bases. You have to push that rectangle into space so that it can hold volume. You have to create a hole. So imagine that you're pushing this rectangle down, and that's what's creating that three-dimensional space. If you never leave the rectangle, if you use 6 times 2 and then you do times 2 or times 6 again, you never leave the rectangle. You have to leave the rectangle to create 3D space. 12 times 4 is 48, so the volume, or what it would take to fill that shape up, is 48 cubic meters, meters cubed. Okay? Now, this next one is also a prism. You can tell that it's a prism because there are two bases that are the same. There's no apex. Okay, now what's tricky here is that the base is not the rectangle. The base is this trapezoid. Remember, congruent and parallel. Now, these two rectangles, the top and the bottom, they are parallel, but they're not congruent. The only thing that you have that's congruent is parallel is this trapezoid and then this trapezoid that's on the back side. So this is my B. This is where I'm going to get my area of my base. And then the distance between those two bases, remember that other base is back here, is we want to know the distance between those. That is 15. So that's going to be the H that I use for my volume formula. I recognize this as a prism. I go to my formula chart. I find my volume. They're right down here. The volume of a prism is the area of the base times the height. So I go find it. Now, area of a base. The base is a trapezoid. So we go back over here and we find our trapezoid. So the area of a trapezoid is 1/2 the sum of the bases times the height. Now these are the bases of the trapezoid and the height of the trapezoid. So let's go back over here. Ignore everything else. So you've got it's 1/2. Base 1, which is 23, base 2, which we don't have, but it's the same as that, 18. So 23 plus 18, that's base 1 plus base 2, and then times the height. It's the height of the trapezoid. We're not using that one yet. We just want to look at the trapezoid, which is 12. Be careful typing that on the calculator. You can let it do all the work for you. 1/2, 23 plus 18 times 12. and you get 246. That's the area of the base. You're not finished yet. That's just your B. Now you have to get your height to find your volume. So imagine pushing that trapezoid, that front trapezoid, back into the shape until you get the bottom one. You're creating this trapezoid-sized hole, right? So area of the base, which is, so we want BH, volume is area of the base times the height. So that is 246 times the height, the distance between the trapezoids, which is 15. So 246 times 15 is 3,690 cubic feet, or feet cubed. Volume is always in cubed measurements, right? Cubed units of measurement. All right, so we want the volume. We want the volume of this shape. This shape is a prism. Okay, so find the bases. You want parallel and congruent. I have congruent, but I don't have parallel. Well, I have congruent, but none of the rectangles actually are congruent to each other. But the triangles are congruent and parallel. So that's what I always want. So there's your big B. There's your base that you're going to do. There's your big B. And then your height. Remember, there's your other base because we always have two. And then with a prism. And then that's the distance between them. So that's your H. That's what you're going to use for your volume. Volume is the area of the base times the height. So I need to find the area of the base, and I need the height. I have the height. Now I need the area of the base. That's a triangle. We go over here and we find our triangle. The area of a triangle is half the base of the triangle times the height of the triangle. So just look at the triangle, right? Just look at the triangle. So you want half the base of the triangle, which is 12, times the height of the triangle, which is 5. I know that I have that, they're perpendicular. 12 times 5 is 60. Divide that by 2, and that's 30. So the area of the base is 30. Now we've got enough. So the area of the base is 30. The height is 14. And 30 times 14 is 420, and that's meters cubed. That's how much it would take to fill up that solid triangular prism. Okay, last one. For prisms anyway, this is a prism. I want the volume of this prism. That means I need the area of the base times the height. So you have to go determine the base and the height. Well, remember that your bases, your B, is always in a prism. They are always parallel and congruent. Well, I have lots of parallel and congruent, but remember, in any prism, if you have a shape other than a rectangle, that is the base. That's what you want to use. So in this case, we want to use this hexagon. There's another one on the bottom just like it. It doesn't even matter, even if this was turned over sideways, right? Even if it was turned this way, you would still use that's the base. It's not what it's sitting on. Be careful, don't make that correlation. It's not what it's sitting on. That's the base, and that's the height. That's how far between the bases. That's the H that we need. So we know we have the H. We need the B. All right, how do we get the B? We need the area of a hexagon. Well, it doesn't say hexagon anywhere on this formula chart. So we're going to go with regular polygon, okay? Regular polygon, 1/2 AP. Remember, A, lowercase a stands for the apothem, and then P stands for perimeter. So this is my apothem. Remember, it's the distance from the center to the side of the polygon. So we want to find our B. It's 1/2 AP. So 1/2 6.93 times the perimeter. We don't have the perimeter straight out, but I do know that it's the sum of the sides. So it's 8 times 6, which is 48. Now remember, this right now is just finding the B. So 1/2 times 6.93, the apothem, times the perimeter. And you get that the area of the base is 166.32. That's the area of the base. That's what goes right here, 166.32. Right? We do a lot of work, but we got to get there. That doesn't, just because we get an answer doesn't mean we're done. So we take that answer, we multiply it by 19, and we get 3,160.08, and that's feet cubed. Okay, cubic feet. That is how much that will hold if you were to fill that hexagonal prism up with water. All right, so let's look at cylinders. Cylinders is very similar. Again, you look at your formula chart. We have a cylinder. It is pi r squared, which is the area of your circle, times your height. So we're doing exactly the same thing that we did for a prism. It's the area of the base. It's just now the base is a circle. It never changes. That's why we like cylinders, because the base never changes. So it is the area, the volume is the area of the circle, the area of the base, times the height of the cylinder, the distance between the circles. Okay, so we want, that's your base, right? Area of the base if we continue the way we're doing, and that's the height, which is the distance between the circles. We want the volume of the cylinder. Volume is equal to pi r squared h. So pi times r squared times h. Okay, now remember you can leave your answer exact, so just do everything except the pi key, right? 3 squared times 6 is 54. So you can get an exact answer of 54 times pi, just like you would do if you were doing x times 3 squared times 6, you would get 54x. But if we want to round to the nearest, right, we can take 54 and go ahead and multiply it by pi, type it all the way out, and you get 169.6, and that is meters cubed. Okay, so formula is really easy to use. Let's look at a word problem. Madison made a cylindrical vase. That's important. You want to know the shape, right? A cylindrical vase for her art project. The vase has a volume of 454. So 454 cubic inches. And a diameter, which remember the diameter is all the way across the circle, of 8 inches. What is the height? That's what we're looking for. The first thing that you need to do is decide which formula you need to use. We're talking about a cylinder and we're talking about volume. Always set up your formula. Volume is equal to pi r squared h. Don't worry about trying to solve it or do anything special with it yet. Just substitute in your numbers. So the volume that I had, just everywhere you have a variable you can substitute, do. Volume was 454 equals, pi is just pi. R, right, be careful, it's not 8. The radius is half the diameter, so the radius is 4 squared, and then h. Okay, so here's what you want to do. Let's go ahead and simplify. Do all the math that you can do. 454 is equal to, let's go ahead and get a number, pi times 4 squared. That is 50.2655h. We never want to divide it, and we never want to round until the very end of the problem. So now what you want to do is either you want to keep all the decimals that you can, or you can do it like this. You can do 454 divided by, and then go up and say, I want to divide by that number, and hit enter. Then you don't have to retype it. You just can get it automatically. So we want it, because we're doing this, we're trying to isolate that variable. Those cancel out to 1. Right, they reduce to 1, and you get 454 divided by 50.2655, and you get that there is a height of 9. Now let me show you 454 divided by, say, 50.3. In this case, it doesn't affect the answer, but if your numbers were much larger, it would make a difference. That's why we never want to round to the end. Last one, ice cream is sold in 2 different containers. The first container is a cylinder with a radius of 4.5, and a height of 11. The other container is a rectangular prism with a length of 9, a width of 6.5, and a height of 11. Remember, you've seen rectangular prisms before. It's just length times width times height, right? That's how you've done it in the past. So that's always good with a rectangular prism. It just doesn't work because length times width is the area of the base. That's the area of the rectangle. So the question says, what best describes the relationship between the two containers? The volumes are equivalent, the volumes cannot be determined, the prism has the greater volume or the cylinder has the greater volume. So what we want to do is we want to calculate the volume for each of the shapes. Well, the volume for the cylinder is pi r squared times the height. Okay, so pi times r squared times the height is 699.79. Okay, then notice they're about the same width, right? This is about 9 inches wide and this is 9 inches wide. So they're about the same width. So we just want to see what the difference is and how much they hold. And they're both the same height too. So it seems like they're very close to each other. So we'll see the difference though. It would be the area of the base, which is 6.5 times 9, and then times the height, which is 11. 6.5 times 9 times 11 is 643.5. So the rectangular holds 643.5 cubic inches of ice cream. The cylindrical holds 699.79 cubic inches of ice cream. And they're about the same size, except the cylinder, you can get, they're rounded, so you have some in the corners. But it does, you can see that it makes it bigger even though it seems like you would lose some space. So the cylinder has the greater volume, okay? So volume of a cylinder, volume of a prism, all comes down to one thing. The area of the base times the height. You're going to take that base and you're going to push it into space to create a hole where you could pour something into to fill it up.